Imagine building metal parts in space. With 3D printing and zero gravity, astronauts could one day create what they need right where they are. And with powerful Laserline diode lasers, melting metal in orbit becomes a reality. We visit scientists exploring the fundamentals of metal 3D printing and weightlessness, the future of manufacturing beyond Earth.
In laser cladding, we are typically focusing on applications like wear protection or corrosion protection, sometimes wear applications, and also sometimes applications like additive manufacturing. So we are using metal powder that we are blowing on the surface on the base material, and then we are using a laser source to melt these particles on the base material. And now the question is, would these applications also work in space and with zero gravity? Therefore, we are here today in Hannover at the Leibniz University, and we will have a look at these applications. Yeah, Christoph, thanks for having us here in the Institute. You're one of the experts for zero gravity. May you give us first insight about how zero gravity also works here on the Earth?
Yeah, welcome at the Leibniz University Hannover at the Einstein-Elevator. Let me introduce to you the Einstein-Elevator and how it works. We want to do microgravity research for large-scale experiments with a high repetition rate, and therefore we put an experiment inside a gondola and catapult this gondola 27 meters up and down, and on this vertical parabolic flight we have microgravity of 4 seconds.
Okay. Can you give us a rough approximation about the weight and the size of this gondola?
So these experiments can have a diameter of 1.7 meters, height of 2 meters, and a payload mass of up to 1,000 kilogram. And in total, we move in this setup 2.7 tons, the drive system, on this vertical parabolic flight trajectory.
All components are inside the gondola, means laser components and whatever?
So these experiments are built to run autonomously, and every component, every part of the experiment needs to be automated and built inside the experimental setup. And this experimental setup is then put inside the gondola, and this gondola is then flying inside the Einstein-Elevator. So you need power supply, communication, and also laser components, cooling. Every topic needs to be done inside the experiment.
And when looking at the overall job of the Institute, do you have, what kind of research fields are you currently working on?
So we are working in different fields. We have two major topics. One is quantum technology, and the other one is looking into additive manufacturing processes for the use in space, for example. So can we bring, for example, a process in orbit or on the lunar surface, later to Mars, and how these processes has to be built for a proper usage later.
Okay, perfect. So thank you very much for that point. So the details of the application, especially for laser cladding, we will now see in detail. Thank you very much.
You're welcome.
Yeah, welcome in our lab, where we are preparing all our experimental setups and where we are making the parameter studies before we are going to the Einstein-Elevator for the microgravity flights. So this is an experimental setup for the laser powder directed energy deposition process. We developed this common process here on Earth for the special environmental conditions of space. Mm-hmm. And therefore we have several main components. For example, the process chamber, the electronic devices where we are controlling all the actuators and the sensors. Then we have our diode laser system. We bought this system because Laserline developed this device especially for rotary and high acceleration environments. We have the battery storage system, especially for the laser, and then the powder conveyor, which is a important device for this setup, and therefore a pneumatic system, and last but not least, the cooling circuit system.
So basically what we see in your chambers seems to be a pretty common and conventional solution for cladding applications. We see in optics a conventional nozzle. What is specific for your application here?
Like you said, so the components you can see here are common devices. The powder nozzle you can see here, the manipulator system, the processing optics we are using to manufacture the specimens. When the process specimen plate is on the higher position with a small distance to the powder nozzle, then we are able to produce the specimens. Therefore, we have here our small demonstrator. You can see here the powder nozzle system where this laser beam is coming out of the center. The focus of the laser beam is at that position where we want to manufacture the specimens. And in this case, this powder nozzle has 6 outlets where the powder gas mixture is coming out.
Mm-hmm. During the flight, so I believe this is already a real part that you produced. During the flight, do you produce that continuously or is it step by step?
During flight, we have 4 seconds of microgravity, and in this duration, we are just manufacturing 1.5 seconds. Because the other time we have to cool down our specimens because of that the deceleration of the Einstein-Elevator has no influence anymore to the melt pool and the microstructure properties. And here we can see the powder conveyor system, which was developed by the Otto von Guericke University Magdeburg. And with this device, we could reduce the degrees of freedom for the powder particles. So the particles have just one way to the process chamber, to the nozzle. So it works like that we have the powder container, which could rotate and could move up and down. And then at the bottom, we have this Archimedean geometry. So the particles are going to the center. Then we have 2 tubes. One is filled with pure argon which catches the particles, and then it's going up as a powder gas mixture. And all in all, we could show that we are able to manufacture specimens in the environmental conditions of space.
Looks already like an already working system.
Yeah.
What are the challenges until now?
We have shown that we are able to manufacture the specimens under the conditions of space, but now we want to have a detailed view or more detailed view into the influence of gravity. So we have seen that the volumes of the specimens manufactured in microgravity environment, that the volume is higher in comparison to the volume of the specimens manufactured here in the lab. So in fact of that, we have to develop or integrate a system like that, which is a splitting system, and with that device we want to reduce the amount of the mass flow in the microgravity to have then a constant mass flow in comparison to the Earth's gravity here in the lab.
So yeah, very impressive, especially from scientific view of this system. What is the future aim of the overall setup?
Yeah, in comparison to other additive manufacturing processes like the powder bed fusion, we are able to coat, to manufacture and repair components in space. And we could use that to manufacture habitats or whole infrastructure for human being on Mars and Moon, for example.
Yeah, thank you, Marvin, for the very impressive insights here into the future of additive manufacturing. Further information about the topic you will find here. See you next time.